Welcome back to Maths with Mrs. J. We're now at the point where I want to explain to you how do you tell the difference between a function and just a relation. Now, every function is a relation, but not every relation is a function. Let me just say that again. Every function is a relation, but not every relation will count as a function. Functions are a subset of all relations. How can we tell? In everyday English, what it means to be a function is that for each x value, there is at most one possible y value. In practical terms, what we do is we call the vertical line test, and I will do some diagrams here and I'll show you how that works. Let's graph the first one here. This is going to be a straight line. It's a linear function. Let's just think about it for a minute. The x-intercept occurs when y is 0, so x will be 3. The y-intercept occurs when x is 0, so y will be 4. So this is going to be a straight line that's going to look like this. You just move it into place correctly. That sort of thing. Now, having a look at this. From a logical perspective, we know that for each x value, there is only going to be one y value. So it should, in theory, pass the vertical line test. Let's just check that it does, in fact, pass that. So we're going to draw a vertical line. And what we're going to do is we're going to move it along the function. And if at any point it touches more than one point on the line, then that automatically rules it out. Even if it's only at one point, automatically rules it out from being a function. This is a function. There's only one y value for each x value. So this is a function. So this is a function. Just for interest, the domain and range are both going to be the set of real numbers. Let's have a look at this. We did a circle in our previous video. This is a circle with center at the origin and a radius of 6. So let's draw that circle. Just move it into place. Something like that. Okay, now this will be 6, this will be -6, this will be 6, this will be -6. It's pretty obvious that for many x values, in fact, every x value except at -6 and +6, there will be more than one potential y value. So this will not be a function. Let me just show you the vertical line test on this one. When we do our vertical line, you'll notice that at many points, it's touching more than one point. At the very edge here, it's only touching one. At the very edge here, it's only touching one. But if at any stage it touches more than one point, that rules it out as being a function. That is not a function. This one here, we haven't looked at the absolute value function before. This could actually be thought of in terms of a piecewise function. Absolute value basically means that if it's negative, you make it positive. All right, so this is, you could write this as x if x is already 0 or positive, negative x if x is negative. So what this is going to look like is going to be like a V shape here. So we're going to get the graph of y equals -x for that part of the function, and then the graph of y equals x for that part of the function. All right, let's think about this. Pretty obvious that for each x value, there's a maximum of one y value. In fact, there's exactly one y value. The vertical line test here, let's just do that just to double check. So if we move that across, at no stage do we touch more than one point on that graph. So that is a function. So that is a function. This will have real domain. What will the range be? So the domain will be the set of real numbers. The range, well, because we've done absolute value and we've turned anything that would have been negative into a positive, the range will be everything from 0 and above. And probably my favourite way of writing that is R plus union 0. That's probably the quickest and easiest way to write that. This one here, by the way, the domain is between -6 and 6, and the range is also between -6 and 6. Circles are not functions, all right? These two examples are functions. In our next video, we're going to talk about function notation and how we use that.